All right, now that we know how to deal with the interior angles and the sum of the interior angles, we're going to try to take the next step. So what we're going to do is we're going to focus on, well, what if I'm dealing with exclusively regular polygons? So I'm still dealing with polygons where all the sides and angles are the same. So each of these instances we're going to look at would be instances where all the sides and angles would be the same. Well, we know how to find the sum of the interior angles. In this case, we take 3 minus 2 times 180, which is 180, which we already knew about. But what if I ask you, well, what's the measure of each of the angles on the inside? Well, since it's a regular polygon and they have the same measure, I should be able to take the total, the 180, and divide it by how many we have. So in this case, we have 60 degrees, which again is a fact we already knew about equilateral triangles. I can do the same thing with my square over here. First of all, we have 4 sides, so 4 minus 2 times 180 is 360, which we already knew. I've got 4 of these angles, so if they're all the same, I can divide by 4. And that's another way of showing that all the angles were 90 degrees. Let's look at the 6-sided figure. Well, the 6-sided figure should have a sum for the interior angles of 4 times 180, or 720. I've got 6 of those angles, so 720 divided by 6 tells me that each angle is 120 degrees. So when it's a regular polygon, it's not too bad to figure out how many degrees I have for each angle. Well, those were all talking about interior angles. Sometimes we also want to look at what are referred to as the exterior angles, or the angles that, if I were to extend out one of the sides, the angles that are created there. Over here, if I extended out one of the sides, I'd be talking about these angles on the outside. Let's see what we have. Well, if I already know this interior angle is 60, that means the angle next to it should be 120. Over here with the 90 degrees, I know these add up to 180, so that means the one next to it has to be 90 degrees. I can do the same thing down here. Each angle is 120, so the angle next to it should be 60. So if I ever look at each interior angle, well, the exterior angle next to it should really be supplementary, or it should be its supplement. Well, what about if I did the total then for those exterior angles? Well, for the triangle, I've got 3 that were each 120. Or in other words, my total was 360. Over here, I had 4 of them. All those outside or exterior angles were 90. I get 360 again. The 6-sided figure, I have an exterior angle of 60, and that would be true in each of those places. And so the total is 360. So it's kind of nice when I look at the sum of the exterior angles, I end up with 360 degrees all the time. And if you think about it, the more sides I add, the smaller the sides get, which means I'm getting closer and closer to having a circle. And we know that circle is going to have 360 degrees. All right, well, how are we going to use that? Well, here are a few examples of what you might see, and something that we'll work on especially a lot tomorrow. This first example here says that Gerardo drew a regular polygon. He found out that the exterior angles each measured 40 degrees. He wants to know how many sides did his polygon have. And then he wanted to know the name for his polygon. A lot of times what I like to do is I like to set up a table. And notice my table here that I have. Now, I may not need all these pieces all the time, but they all have relationships between one another. So notice in our table, I've got the number of sides, which a lot of times we call n. We've got the sum of the interior angles, which we know I can find if I do n minus 2 times 180. I've got the measure of each interior angle, which I know I can find by taking this total and dividing it by how many sides I have. Over here, I've got the exterior angle sums. Well, I know that these two together have a sum that equals 180. The nice thing about exterior angle sums is they're always the same value. They're always 360. So here's how I might use the table in solving a problem like the first one. So again, it says that Gerardo was going to draw a regular polygon. It had an exterior angle that's 40 degrees. So I'm going to fill that in. What he wants to know is how many sides did his polygon have? Well, we can do this a few ways, but anytime I'm looking at something and they tell me each angle, I want to see how that relates to the total angle measures. Well, they talked about exterior angles, and the exterior angle sum is always going to be 360. So if my total is 360, each one is 40 degrees, I should be able to divide those two to see how many of those we have. And in this case, that would be 9. Well, that means I have 9 angles, but it also tells me I have 9 sides. So for this problem here, they want to know how many sides did he have? Well, he had 9 sides, and we know a 9-sided figure would be a nonagon. All right, let's do another example where we might use the table to help us out. Part B says, I've got a polygon. The interior angle sum is 2,520. So I'm going to fill that into my table. My goal is to figure out, well, how many sides does it have? All right, well, if I knew the sides, I know I can use this formula, the n minus 2 times 180. And that would give me my total. Well, now I know the total. So what I'm really going to do is I'm going to kind of think backwards. Well, in that formula, we said n minus 2, and then we multiplied by 180 to get my answer. So the first step I'm going to take is I'm going to take that total of 2,520. And if I were to set it equal to that formula of n minus 2 times 180, well, I would probably start out by getting rid of the 180. So I'm going to divide both sides by 180. So when I do that, that 2,520 divided by 180 gives me 14. So now I have this, n minus 2 equals 14. And I notice all that, I just had to add 2, and I find out that I had 16 sides to that figure. So I use the table to kind of help me organize things. And in fact, as we get to more and more problems, I sometimes will give you this table, and I'll give you one of the values to fill in, and we're going to see if we can find the other values that go with it. All right, but let's see if we can use the table again to help us with these last 2 questions. So the first one says that we have a quadrilateral that has 4 sides. So I know that. They want to know what's the measure of each of the interior angles. Well, with a 4-sided figure, we can find the sum. So n minus 2 times 180 means really 2 times 180. We can find the measure of each one if we divide by how many sides we have, and we end up with 90 degrees. Then I look at part D. Let me backtrack to part C for a second. I actually kind of made a mistake on this one because all they told me was this was a quadrilateral. They didn't tell me it was a regular quadrilateral or a square. So actually, part of this information I could not find. I could still figure out that the sum of the angles is 360, because that's still going to be true. However, I really should not have been able to find this one here. So I got to be careful, and I made the mistake here. I got to be careful because if I want to find the measure of the interior angles, I have to know it's a regular polygon. So technically, I don't have enough information for that one. All right, so don't make the mistake I just made on that one. Make sure it's a regular polygon. All right, part D. What's the measure of an interior angle of a regular 360 gon? Or in other words, we have 360 sides. We want to find what's the measure of one of the interior angles. All right, well, I can use my formula if I want to. So I could do 360 minus 2, multiply that by 180, and I get this, 64,440. That's the sum, that's the total of all of them. So to find one of them, I can divide by 360 because that's how many sides we have. And we find out that each angle measure would be 179 on the inside. They said, is there more than one way to find this? Well, we just focused on the interior angles, but there might be a way we could find this by, first of all, focusing on the exterior angles. Well, I know I have 360 sides. I also know the exterior angle sum is 360. So if the total is 360, I've got 360 of those angles. I should be able to take 360 divided by 360, and that would tell me how many degrees each exterior angle is. So each exterior angle had 1 degree. Then we know these two, the interior angle and the exterior angle, have to add up to 180. So if the exterior angle is 1, that means the interior angle should have been 179. So just kind of an introduction to some of the pieces here that we might have to find, depending on the information we're given. Tomorrow, like I said, we're going to spend a lot of time practicing these type problems and trying to figure out, okay, I'm given this information, what else can I find based on that information? So this is kind of a lead into the main idea that we'll do tomorrow.